Hi, this is the flight computer of the Granat 4 Russian drone. There is a circular connector here, pitot-static input pressures. Okay, so we can see the construction of that thing. You can see the enclosure made with an assembly of different PCBs. We can see the solderings on each corner. Okay, first we can see here two pressure sensors. We can see that the sensor on the right here has two input tubes. So this is actually the sensor for the airspeed. One input corresponds to the total pressure, which is on the pitot tube. The second one, static pressure, which is also the pressure which is applied to this second transducer, which permits the measurement of the altitude. We have here a sensor which is sensitive to the difference of these two pressures. And this sensor is an absolute sensor, which permits the measurement of the static pressure, which is negative. I mean the pressure which is below the pressure at sea level. So this is the schematic diagram concerning the pressure sensors. Both sensors deliver a DC voltage. The output voltage of the static pressure sensor is here. It is connected to this amplifier. So this is an op-amp with the marking BUQ. I think it's an OPA 376. Anyway, it's an op-amp, so we can see that there is a gain and there is also a bias of 2.5 volts at the output here. And the gain is approximately 18. The output voltage is divided by 2, and this voltage is fed to an auxiliary ADC, which is present on this part here. And there is also a DAC. The DAC permits to correct the output offset here. So this permits to adjust the altitude. This is a dynamic pressure sensor. The output is fed directly to the ADC input of a second gyro here. Both sensors are supplied with a reference voltage, which is given by this part. It's a low-cost voltage reference, max 6105, approximately 50 cents. Well, the stability is not the best, 70 ppm per degree approximately, but for 50 cents you cannot expect more than that. The amplifier is located on this area. You can see that we have two identical modules here, the red gyro and one accelerometer here. Well, this is the pinout of that module, the red gyro and the accelerometer. Okay, there is a power supply voltage. There is an auxiliary ADC for the pressure sensors. There are two chip select, one for the gyro here, second one for the accelerometer. And there is an SPI bus, a clock, data in, data out. The chip selects are here. This microcontroller delivers actually 3 pulse width modulation signals for the servos. The pulse width modulation signals come from port 6. There are actually 8 possible pulse width modulation controls, but only 3 of them are used. Okay, so we have this one, pulse width modulation number 3, and 4 and 5 here. Now this is the schematic diagram of this small board. I didn't find the datasheet of this part. So we can see that there is a reference voltage here, 2.5 volts, and it seems that there are two outputs here. And this board has a connector here for the power supply. It is this small connector here, and there is this 4 pins connector, which corresponds to this connector here. There is a ground and these two outputs, which I assume to be outputs here. It is maybe a magnetometer in order to measure the Earth's magnetic field, but I am not sure. But maybe what we can do is to supply this board and see if we have something at these two outputs here. I have tested this little circuit. So first there is a voltage here of 3.3 volts. Second regulator gives a voltage of 1.8 volts. The reference voltage is 2.5 volts. And at the output I have found voltages of 1.8 volts constant. So this is probably open drain or open collector. Okay, but I don't know exactly what is the purpose of this part.